Okay, we ever take a tricky integral from the Chennai Math Institute 2025 finals number 3. We have the integral from 0 to pi over 2 square root 1 minus 2 sine 2x plus 3 cosine squared x dx. Okay, before we do anything, I think what we need to do is just factor this somehow. Particularly, we're going to want everything with just one angle. I mean, I guess we could do it a different way, but I don't really like having a double angle here. So for my starting point, when I rewrite this, we'll use the double angle formula on this. We'll pull a 2 out. So then sine 2x can be written as 2 sine x cos x, and then we have the rest of this. And then from here, what I wanted to do is just try to factor this, maybe kind of doing a substitution, like calling cosine of x, y, and sine x, w or something. There's a couple problems with it though. If we do it where we have our constant terms positive and then this term's negative, and also I don't think it really factors with integers. So this is a good case where we can do the trick where we take this 1 here and we rewrite this in terms of sines and cosines. So for 1, I can write it as sine squared x plus cosine squared x. And then cleaning this up, this here is going to be a 4, right? So we have minus 4 sine x cos x. Now let me reorder this and combine like terms. So we have cosine in common here. So how we'll do that is putting those together, we'll do it as 4 cosine squared x. Then these are going to be like our middle terms, minus 4 sine x cos x, and we'll put the sine squared on the end. But now I think we're all set because this here is going to be the same thing as 2 cosine x minus sine x all squared. Now before we take this and put it back in the integral, let's just keep in mind that this whole thing is under a square root, okay? And so the tempting thing to do is just be like, oh, just cancel it, and that works sometimes. But when we look back at our bounds, where 0 to pi over 2, that's first quadrant, this is not always going to be positive, so we can't just cancel it like that. We need absolute value on it. We're going to need 2 cosine x minus sine x. And it's because in some places this is going to be positive, in some cases it's going to be negative. If we all we care about here is the first quadrant. If we just had cosine and sine, the break-even point would be at pi over 4. But it's not true here with the 2. It's going to be kind of weighted. So our break-even, meaning where it's going to be 0, it's going to be, I don't know, it's going to be somewhere in this area, right? Because the 2 is going to kind of push it that way. So before I put this back into our integral, I want to get rid of the absolute value sign. I need to know this break-even point. Let's call this thing t, and then we can create a little equation over here to find out, okay, what is t going to be? We want just 2 cosine t equal to sine t. I can divide off cosine t on both sides, and then we've got tan t equals 2, or solving for t, we get t equals just arctan of 2. So now I think we're ready to put this back, but we'll break it up into cases because our integral is going from 0 to pi over 2. We'll break it into 2 integrals. We'll have one going from 0 to t, and then the other one going from t to pi over 2. So let's see how that looks. Okay, so here now we have it broken up. I dropped the absolute value. Just looking at the first one, I should mention, right, everything over here, well, I guess along here, it's always going to be positive. The cosine values are going to be larger from 0 to t. And so that's why here in this one, we just dropped the absolute value. But over here, everything's going to be negative. The sine value is always going to be greater than 2 times cosine x here. So in order to drop the absolute value here, notice I just reversed it, just reversing the sign. But now we get 2 easy integrals. We'll just go ahead and integrate. We'll worry about t later. That's going to be easy to deal with in the end. So first, integrating here, this is going to be 2 sine x. Here, integral of sine x is going to be minus cosine x, or minus sine x is going to be positive cosine x, so we have that. Then on the second one, integral of sine, that's going to be minus cosine x. And here, this is going to be just minus 2 sine x. We'll go ahead and just plug everything in, so we'll just leave the t for now. So we'll have 2 sine t plus cosine t, then minus plugging in 0. That first part, sine at 0, that's just a 0. This is going to be cosine at 0 is going to be a 1. Then evaluating a pi over 2, cosine pi over 2 is 0. minus sine of pi over 2 is 1, so this is just going to be a minus 2 here. And then plugging in a t, here we'll have minus cosine t minus 2 sine t. But here we can do minus times minus is plus on both these. Combining like terms, we got sine and cosine here. So let's see, 2 sine t plus 2 sine t. That's going to give me 4 sine t. Cosine plus cosine gives me 2 cosine t. What's left here? Just minus 1 minus 2 gives me minus 3. And all that's left, we just need to evaluate these t terms. We don't want to leave it this way. And we can do that. I don't really need to plug it back in directly. We can use the triangle and get a value for sine t and cosine t. So drawing this right triangle with an angle of t here, what's going to happen? We know tan t is going to be 2 or 2 over 1. So we can do opposite over adjacent as 2 and 1. Use the Pythagorean theorem. The third side is going to be just square root of 5. So what that tells us is sine t is going to be opposite over hypotenuse, or 2 over square root of 5. And then for cosine t, adjacent over hypotenuse, 1 over square root of 5. So then we just plug it in, 4 times our sine value. That's going to be 4 times 2, or 8, square root of 5, plus 2 times this one is 2, square root of 5 minus 3. Combine these first two terms and we get 10 over square root of 5. But let's get we could actually leave it, but let's rationalize it doing this, just multiplying by 1. That way this thing here is a 5, so we can cancel 10 over 5. That's just going to give me a 2. Put that together, and so for the final solution on this, we just get 2 square root of 5 minus 3, and that's it. Okay, there you go. Good one from CMI 2025. Thanks everyone for watching. Have a good day.